Welcome one, welcome all. How are you guys today? I'm glad to hear it. I hope you guys are well. I hope this does nothing to change that. It is Tuesday, our second happiest day of the week. The board already has some writing on it because we had someone join us mid-problem. I was excited to actually have an actual studio audience today, so I thought I'd just start over. Let's see. So I thought that I would do a couple problems involving lenses and a couple of problems involving correcting vision. And so our first problem is we are told we have two converging lenses. The one on the left has a focal length of 15.8 centimeters. The one on the right has a focal length of 20.9 centimeters. And we're also told that they're placed 28.4 centimeters away from one another. We're then told that we place some object out there, and the resulting image is upside down and halfway in between our two lenses. We want to know how far to the left of the leftmost lens is the actual object. And so I'm going to start over in what I was saying. I hadn't put this picture up, so I think part of this is I wanted you to be able to sort out just from the words what the setup was. So the leftmost lens here has a focal length of 15.8 centimeters. The rightmost lens, 20.9 centimeters. They're 28.4 centimeters apart from each other. We're told that ultimately an object placed over here to the left at some distance p1 from the leftmost lens produces an image that is inverted and halfway between the lenses. And so this probably seems harder than it really is. It's really not that bad, but the trick is we have to work backwards, because what we know is where the image from the second lens wound up. Since it's halfway in between, half of this 28.4 is 14.2 centimeters. We know that Q2 is minus 28.4 centimeters over 2 is minus 14.2 centimeters. That's this. So this is Q2. And it's equal to minus 14.2 centimeters. Hooray. Awesome. Okay, so then we have our standard lens equation, right, thin lens equation, that 1 over P2 plus 1 over Q2 is equal to 1 over F2. Maybe I should subscript this as F2 and F1. So we could use this to solve for P2. We could say that 1 over P2 is 1 over F2 minus 1 over Q2. No magic in that, I just brought this to that side. And then I can multiply top and bottom of this one by Q2, and top and bottom of this one by F. Now they're over like denominator. I can say that 1 over P2 is Q2 minus F over Q2 times F, 2. Yeah? And then I can just flip. So that P2 is Q2 F2 over Q2 minus F2. Plugging in values. Let's see. Q2 is minus 14.2 times F2 was 20.9 divided by 14.2 negative minus F2 is 20.9 equals about 8.455, which coincidentally is what I've already gotten. Yay?
Yes.
So if I come back to our drawing, that tells me that this is P2. Yay? But remember, P2 is the image from lens 1, right? The object for lens 2 is the image for lens 1.
Oh, so lens 1 is the object of lens 2.
And so now we know where the image from lens 1 wound up. It wound up right here. Okay? And so we know that this distance is 8.455 centimeters. We know this total distance is 28.4. And so
my question is, how'd you know that the second lens and the first lens were half the distance from each other?
That the image is halfway in between the two. I gave you that in the problem.
That was I.
Yeah. Yeah, so the image is
Halfway
inverted
between
and halfway between lenses.
Okay, and that's why you divide by 2. Okay.
So Q1 is equal to 28.4 centimeters minus 8.455 centimeters is roughly, that's going to be a little over 20. Have I done that anywhere? I did. All right, let's do it again. Oh shoot, and I just cleared it with my calculator. All right, 28.4 minus 8.455 gives me, lo and behold, 19.45. Who knew?
On the top.
Well, I'm rounding a little bit, but. And so now we can go through and say, where did I put that pen? I'm going to be sad about that. Okay. We can write another of these equations, and we can say that 1 over P1 plus 1 over Q1 is 1 over F1. But note that we now know Q1 and we know F1. I can play the same fancy trick here, right? 1 over P2 plus 1 over Q2 was 1 over F2. That told us P2 is Q2 F2 over Q2 minus F2. Similarly, I could say that P1 then is going to equal Q1 F1 over Q1 minus F1. Yay? There was nothing magic about these subscripts leading to this.
Right.
And so I could easily have just called this 1, 1, 1, and I would have gotten that P1, Q1, F1, Q1, right?
Right.
So let's plug in numbers. So $19.945 is Q1, right? That's the value we just got. Minus 15.8 is F1. And then shift 1 over x times 19.945 times 15.8. And we get about 76.027. That's way too many sig figs, but. So that tells me that this object is about 76 centimeters to the left of the left lens. Yay? We're happy-ish with this?
I am at least.
Awesome. Anyone else in our audience have a... okay, so let's try another one before we shift gears a little. So this time, I give you an object placed 60 centimeters from a converging lens, and I tell you get a real image. If we then move the object to only 40 centimeters away from the lens, the image is actually 10 centimeters further away from the lens. We want to know what is the value of the focal length of this converging lens. So the trick here is in the original case, oh wait. In the original case, we had Q. And that was okay. In the new case, we have Q plus 10 centimeters. Is the image location, right? So we've got that our standard equation, 1 over P plus 1 over Q is 1 over F. Well, it's the same lens in both of these cases. And so I can say 1 over P1 plus 1 over Q needs to equal 1 over, I don't know, P2 plus 1 over Q plus 10 centimeters. Because they both equal 1 over F. Right? It's the same lens. And so this needs to be true for both cases. So this was case 1, this was case 2. And so now we have this ability to make group termed style argument where 1 over P1 minus 1 over P2 is equal to 1 over Q plus 10 centimeters minus 1 over Q. Does that work?
Yeah, you just moved everything
Yeah, I just put all the P's, so,
to one side.
right, both of these are equal to 1 over F. So I brought the P's to one side and everything with a Q on the other side. That works?
Yep.
Okay.
Common terms on the same side.
So there's a neat trick we can play here that we just played here. I could multiply top and bottom of this one by Q, and I could multiply top and bottom of this one by Q plus 10 centimeters, right? If I do that, it's the same as multiplying this first one by 1 and this second one by 1. So if we do that, yep, we get that this is Q minus 10 centimeters over Q times Q plus 10 centimeters. Yay? What nice thing happens on the top?
Q's cancel.
I just get the 10 centimeter piece, right?
Yeah.
So I get that 1 over P1 plus 1 over P2 is equal to minus 10 centimeters over Q times Q plus 10 centimeters. Yay? But we know what P1 and P2 are, right? P1, P2. Right? P1, P2. So this, and while we're at it, if you'll forgive me, I'm going to multiply top and bottom of this one by 4 and top and bottom of this one by 6. Oh goodness. So that looks like 4 minus 6 minus 2 over 240 equals minus 1 over 120 centimeters. I don't think Carol Stanton would approve of my board work. But
She's not here to judge.
In spirit, she's. But I'm going to take this term on the far left and this term on the far right. They're equal to each other. And so I can say that, in fact, I'm going to get rid of the two minus signs. And I'm going to say that 1 over 120 centimeters is equal to 10 centimeters over Q times Q plus 10 centimeters. Okay? You see all I did is grab this term and this term. Get rid of all the junk in between. We're happy-ish. Then 10 times 120 is 1200. 1200 centimeters needs to equal Q squared plus 10Q. 10 centimeters times Q. Just cross multiply. Yeah. And rewrite this as Q squared plus 10 centimeters times Q minus 1200 centimeters is equal to 0. What beast is this?
This is the quadratic.
It's a quadratic equation. I'm going to save a little bit of space here. I've already done this problem. So our choices for Q, let's see, Q squared, 10 centimeters times Q minus 1200.
Not that gay?
40 and 30. 10 is 40 and 30.
Squared. It's minus 40 and plus 30.
Yeah. Pass edge brackets.
I hope you did.
So, yay?
Yeah.
But I gave you a piece of information here that will help you discriminate between those two answers. One of them's positive, one of them's negative. Which of those is going to correspond to our real image?
The positive 30.
It's got to be the positive 30. Yay? So now we can come back to our original equation and we can say that 1 over P plus 1 over Q is 1 over F. What was, well, so we could say that 1 over P1 plus 1 over Q is equal to 1 over F. So P1 is 60 centimeters. So we have 1 over 60 centimeters plus 1 over 30 centimeters is 1 over F. I can multiply top and bottom by 2. So I can say that 1 plus 2 over 60 centimeters is equal to 1 over F. Or F is 60 centimeters over 3 is what? 20 centimeters. Yay? And they all lived happily ever after, at least thus far. I live in constant panic that I have forgotten to hit record, and that I've just been doing all of this for an audience of 1 and then 2.
You must have done it more than once.
I did that last week. That's how Susan was here for all of it. Was because I got to the end and I realized I didn't even bring my flash drive down here. It's upstairs.
Oh,
So I ran upstairs, got my flash drive, started, and Susan joined us. I was grateful for the audience then. A little mad at myself that I had to give the same set of problems twice.
That'd make me frustrated too.
But oh well, what you gonna do?
Yeah.
So, yesterday we were talking about bifocals. So I don't know if you guys are young, so I doubt either of you has bifocals, but
I'm the same. We are in the same page.
oh, you are so kind, Susan. If I gave extra credit, you'd get extra credit. If I had a daughter, I hope she would grow up to be someone like you.
So,
Really?
get a dog.
I have a bunch of dogs. So, but they're not well behaved. They're not nice. So, we have bifocals are so that people who have
Nearsighted.
presbyopia, right? I need glasses so I can see far away.
Yeah.
But the problem is when I wear the glasses, they correct my vision so that I can't see up close anymore because now I'm old and my eyes can't accommodate. So bifocals have two different powers, one on the upper region for distance and one on the lower for reading, because when you read you tend to look down, so you're looking at the bottom half of the lens. So this is for close, this is for far. And so this poor person, not poor, fortunate to have lived long enough for this to happen, can really only see clearly now if an object is 45 centimeters away, but not any further than 155 centimeters away. And so she needs bifocals. We're going to look at her right eye. And so we want to return her near point so that where she can hold things and see to about 25 centimeters. That's kind of an average thing that allows you to not have to stretch your arms. So we could say that let's turn this into two problems. We'd say that for the power of the upper part of the lens, right? So that's 1 over f. Remember, power is 1 over the focal length in meters. So we have to do all this in meters, not centimeters. But 1 over f is 1 over p plus 1 over q. And so for the upper part of the lens, what is she trying to look at?
Something far away.
Something far away. So,
155 centimeters.
well, we want her to be able to see things that are further than 155 centimeters away.
Okay.
So we want her to be able to see things that are very, very far away. So what's a good approximation for P? Infinity.
Okay.
So,
Oh yeah, that's what we were talking about yesterday. Is far size infinity.
yeah, we want to let her see an object as far away as possible. And so let's let P tend towards infinity. And then that is just 1 over Q. But what's the furthest away Q could be and still have her see this thing?
I want to say 155 centimeters.
155 centimeters from her eye. Now, the
from
standard thing that we assume is that the eyeglass is a couple centimeters in front of the eye. But
Okay.
again, if it's more or less, you'd have to, but let's assume that I can't draw. I don't know why I'm trying this. This is going to end badly. That looks bizarre, but let's assume that this distance is about 2 centimeters. So you told me 155 centimeters from her eye, but how far is that from the lens?
That's going to be 153 centimeters.
And is that a positive cue or a negative cue if the image is going to be cast back here?
Negative Q. Being cast.
And again, we need to do this in meters, so 153 centimeters is
1.53.
1.53 meters. So what is 1 over infinity?
0.
Tends to 0, right? And so for her upper prescription, I didn't bother to do this one. That's math that I can do in my head or with a calculator. This is about a power of minus 0.654 diopters. That's probably, I don't know that they actually grind lenses to the 0.004 diopter level, but that's ideally about what you'd want. Yay? Okay, so now we gotta worry, oh, does that make sense?
Yeah, that's the upper half.
That's the upper half. Now we gotta worry about her close-up vision. And so, P lower, well, it's 1 over F lower is 1 over P plus 1 over Q. And this time, our object distance, how far away does she want to hold this?
Well,
For the
if-
line?
She wants to be able to hold this 25 centimeters in front of her eye.
okay.
That's kind of just the normal, kind of comfortable for an adult
Yes.
The normal
position to
here.
hold something away. Unless, like me, you know,
No problem.
yeah. Before I caved in and corrected the fact that I have presbyopia, I was starting to have to hold stuff further away to see it. So, but we have that same issue that 25 centimeters in front of her eye, how far is that in front of the lens?
It's going to be 23.
23 centimeters is how many meters?
It's going to be 0.23 meters.
Yes, sir. Yay? And is that plus or minus?
It's going to be minus.
It's plus.
Oh.
Because it's still in front of the lens, right?
Oh, okay.
But where do we want to cast the image? What's the
We want to cast the image behind it.
where can she see? Yeah, we gotta cast to here, right? So that we're putting it far enough away that she can see it, because the closest she can see is 45 centimeters. So where so we've got plus 1 over, what is Q going to be here? What's a good value for Q?
I would make it 45 centimeters.
Except that we're also, it's 2 centimeters in front of her eye.
So 43 centimeters.
So how many?
0.43 meters.
0.43 meters plus or minus?
That's me, minus.
Correct.
That's the minus. Oh, yeah. Okay, I got it back.
And let's see if this is what calculators are made for. I'm getting about 2.02. Diopters. So negative focal length for her distance vision, positive focal length for her reading vision. If you go into, you guys again are too young for this, but if you go into like a CVS or whatever drugstore is near your house, they probably have a section in the back by the pharmacy where they've got some glasses on a stand.
Yeah, like the generic reading glasses.
And those all have positive focal lengths. The readers, they'll apparently sell you without a prescription. So
they're not expensive, as expensive as prescription either.
because you don't need a prescription to get it. I can kind of see the logic in it. It's not like not being able to read up close is going to impair your ability to drive.
Right.
So maybe as someone who's on the roads or sidewalks, I do want someone who needs distance prescriptions to go see an optometrist. Maybe I care less if it's a reading prescription. Just seems unfair as someone who needs the distance prescription that I have to go to an optometrist for it when we can do the physics calculation right here.
But what if they can't tell how fast you're going?
That's a good question. I don't know the answer to that. So,
Sorry,
Nice
officer.
question.
yeah, I didn't have my readers with me. Okay. One more. So, this one is maybe a touch trickier. So, I will tell you, we have a person who, when he turned 50 years old, he needed plus 2.5 diopter reading glasses, the ones we were just talking about, to read a newspaper held 25 centimeters away. Now he's 60 years old, and those same lenses aren't quite enough anymore. So now he has to hold the newspaper 32 centimeters away. Starting to get into that issue of are his arms long enough, right? So if he wanted to go to his local drugstore and pick up a new pair of readers so that he could hold the paper 25 centimeters away, what lens power should he buy now? And so what we first need to do here is figure out what is this gentleman's near point now that he's advanced a little, right? And so we have our statement that the older one, what's a better subscripting here? His old glasses are these 2.5s, and we're trying to figure out his new. So should I say P1 is 2.5 and P2 is the new one, or should I say P old is the 2.5 and P new is the ones he's going to buy?
Yeah, Pinot is going to buy is better.
Okay, so P old then remember is 2.5 diopters. Okay. you probably think that both 50 and 60 are old, but hey,
No, both
that
are
hurt my
young.
feelings. But so we could say that 1 over p plus 1 over q is 1 over f, but 1 over f in meters at least is the power. Yeah. And so we could say that same trick we just played, multiply top and bottom by of this one by q1 and this one by p1. Actually, I don't even need to do that. I don't need to do that. Because I want to solve for 1 over q1. So 1 over q1 is p old minus 1 over p1. Is that all right? So if I multiply, yeah, let's do it this way. I think this makes more sense. This is a problem of only thinking about how you would solve a problem. Let's multiply top and bottom of the old prescription by P1. And then we get that this is equal to P1 times P old minus 1 over P1 times P old. Oh wait. That's not true. Just P1, right?
Yeah, I was like, how do we get P old on the bottom? Okay.
And now I can invert stuff. Is that true? Yeah, that's true. I can say Q1 and then is just P1 over P1 times P old minus 1. Yay? And so if we look at how far away he's holding the newspaper, we can figure out where his near point is, because that's where we're casting the image. Right? So if I badly draw this,
If it's still 2 centimeters.
so there's the real thing, but we're going to cast it out to here. Object image. So let's say P1 0.32 meters. 0.32 meters times 2.5 diopters minus 1. That's per meter. A diopter is per meter, right? And this winds up being, let's see, 0.32 times 2.5 minus 1, shift 1 over x is about minus 1.6 meters. So now we can say that the power of this new lens, that's, by the way, effectively where this near point is. And so we want the P new to be 1 over P2 plus 1 over Q2. We want the person to be able to hold the newspaper how far away now?
25 centimeters.
So is that P2 or Q2?
P2.
That's P2. So we want 1 over 0.25 meters plus 1 over our
Is it negative 1.6?
our Q2 is now going to be our 1 over minus 1.6, or Q2 is going to be our minus 1.6.
What we saw.
And so this is 1 over 0.25 is 4. Right, multiply top and bottom by 4 minus 1 over 1.6 meters. Let's see what we got. Shift 1 over x plus 4 is about plus 3.375 diopters. So when this person goes to the drugstore 10 years ago, he was shopping for plus 2.5 diopter readers. Now he's shopping for 3.375. I don't think they sell them in those. So he's probably got to go to
3.5.
yeah, 3.3. Sorry, 3.5 diopters. So, questions, comments, concerns.
And at 3.5, would he just be holding it a little closer to kind of get that 25 centimeter image?
It would actually let him have a little bit more play as to where he held it.
Oh,
He could
okay.
probably even bring it closer and still see.
Oh, cool.
But at 25, he should still be able to see.
Mm.
So, but he'd actually be able to hold it even closer than that. And still see.
He probably like that.
It does, perhaps, like if, I guess you don't wear glasses, but if you wear glasses that are a little too strong, it can
I put on other people's glasses
be a little
just to make it head hurt.
disturbing in some sense, but I don't think that minor change is going to be that bothersome for him. All right. As always, guys are awesome. Have wonderful days. Thank you for stopping by. Don't be strangers. Enjoy your days, but not so much, and we will see you next time.